Welcome, guys. So keep solving our physics subject GRE. So we start from 96, 60, 69, 61, and hopefully we can get get to a final. Okay, so 61. This question is difficult. Basically, you have long streets and massless rods, but with two or similar mass, same mass here and here. Now it's here. Ask about the p ratio of the frequency of the small oscillation of convolution 2 to the small oscillation of convolution 1. Okay, there's a difficult formula. I don't know, maybe you guys don't know, but I will just write it. Suppose you have a small oscillation and there's an initial momentary inertia respect to this point. Okay, probably this is not good. Something really large, and with relation moment inertia I, and this is the center of mass distance from the center of mass to the pivot. Okay, so the formula is T over 2 pi, so mg LCM over I, the I over this. Okay, so this is the formula. So simple example is the pendulum. Okay, so in the pendulum, what I is just ml square, and so we have 2 pi over ml square mgl. So basically, this is the standard L over G. Right. So this is the formula. Okay. And okay, I will prove this formula in a second. So how about we just first use this formula to get an answer, and then we start to prove this formula. Okay, so we just use the formula. So case 1. Case 1 basically is the same as the pendulum. So case 1 is just this. Because the pendulum result does not change the mass, so does not depend on mass. So the case 1 is just pendulum. The case 2. So you have mg. Okay, remember that now you have 1 is mg L over 2, 1 is mgl. So this is basically the sum of the center of. So you need to suppose you have, because you have two particles, so you need to view this one as the sum of the mgl, and which I is 1 is this and 1 is this. So it's 1 over 2 pi. Mg can be cancelled, m can be cancelled, and L can be there will be one L survive, and it's G, and then this is 3 divided by 2, and then this is 5 divided by 4. So this is 2 pi square L divided by G, and 5 over 6. So the answer is A. The answer is A, because what we'll compute is period and ask about frequency. So period just reciprocal of frequency. So the answer is A. Okay. So now I want to prove this formula. Then we close this problem. This problem is difficult in the subject GRE. So I think maybe this problem is for this. Okay, this problem is good enough for a separate video. Okay, so suppose you have, so basically your Lagrangian is, this is your Lagrangian, and there's mgl. So this all is mgl. So L in this case is just LCM, the mass, center mass, times cosine theta. Actually, because the ground is here, it should be plus half cosine theta. So, and because what we ask is the small list, the small perturbation. So omega just say that dot square is definition, and the Taylor expansion tell you that this can be approximated by this 1 minus theta square over 2. And the good thing is that this first constant term that's not important. So when we write the equation of motion of the Lagrangian, what we have is this minus d over dt, this equals 0. This tell you that so this term is neglect this one. We have this minus mgl theta square. So we have minus 2 mgl theta minus I theta, and the dt. Oh, there's no half here. What I'm writing about. Okay, so square. So we have theta square I plus mgl theta, which is 0. We have I theta double dot mgl divided by I, which is L. So this is omega square. So omega is equal to mgl divided by I, and t is 2 pi over omega. Okay, so we prove this formula. Okay, I think that's it. So this is good for this problem is usually difficult. So I suggest that you remember the formula. Okay, and I will see you guys in the next video.